Hi everyone! Today let's talk about session 3.4, matrix operations. So given a linear system with m equations and n unknowns. So here we have m equations and n unknown. We can write down the matrix vector form. So this is the matrix vector form. This is the matrix A, and what is the dimension? What is the size of it? So we usually use row times column. So we have m rows and n columns. So the size of this matrix is m by n. And then we have the vector x. This is a column vector, and the size is n by 1. Okay, because it has n entries, so n rows. And then we have the b vector. This is the right-hand side of the linear system. And the size of this vector is m by 1. And do you notice that the inner dimension match? So the inner dimension match. So they're the same. Okay, so this is very important criterion for matrix multiplication. The inner dimension must match. Okay, so look at the following example. If A is 3 by 2 and X is 2 by 1, what is the dimension for B? Okay, so for matrix vector or matrix multiplication, we must verify that the inner dimension match, and then the outcome is gonna be the outer dimension. So the outcome is gonna be m by 1 in this case. All right. So now let's see. So 2 match, which is good. And then the outcome is what? 3 by 1. So B is 3 by 1. And then next, the inner dimension match. And then so the outcome is 2 by 1. 2 by 1. Okay. Next one, because the inner dimension, they don't match. So B is not defined. Okay, so alright. So now it's time to define other matrix operations. So let's assume A is m by n matrix with elements aij, where I is the row number, j is the column number. So how do we add two matrices? First of all, they must have the same size. Okay, and then when we add those two matrices, we just add the entries respectively. Okay, so let's look at the following example. Part A. What is the matrix A plus B? Well, we just add the entries respectively. So the 1 entry, we have 3 plus 4. The 1 2 entry, we have 0 minus 3. And then the 1 3 entry, we have minus 1 plus 6. And for the 2 1 entry, we have 2 plus 9. The 2 2 entry, we have minus 7 plus 0, right? And then the 2 3 entry, we have 5 minus 2. So this is the sum of A and B. And let's see, 3 plus 4 is 7. 0 minus 3 is negative 3. Negative 1 plus 6 is 5. 2 plus 9, 11. This is minus 7. 5 minus 2 is 3. So this is the answer of part A. Okay, so we just add the entries respectively. Okay, part B. Wow, notice that A was the size. It has 2 rows and 3 columns. But how about C? C is 2 by 2. They don't match. The dimension don't match. So A plus C is not defined. Okay? So for matrix addition, we must verify that the dimensions match. Okay? Alright. So let's continue. Multiplication, multiply a matrix by constants is just we multiply all the entries by that constant. Okay, so continue with last example, find 3a. Well, 3a is what? We multiply all the entries by 3. Okay, but what is a? Let me see. 3, 0, minus 1. 3, 0, minus 1. And the second row, 2 minus 7, 5. Alright, let's see. So 3 times 3, 9. 3 times 0, 0. 3 times -1, -3. 3 times 2, 6. 3 times minus 7, minus 21. 3 times 5, 15. So this is the answer, 3a. Okay. Alright. How about modular matrix multiplication? So let's say a times b equal to c. So we must make sure the inner dimension match, and then the outcome, the result, is going to be the outer dimension. Right? Okay, so a is m by n. So here it means we have m rows and we have n columns. And then matrix B, we have n rows and we have p columns. The resulting C, we have n rows and we have p columns. So how do we multiply is we use the rows times the columns. For the Cij, we use the ith row of A times the jth column of B. Okay, so we use ith row of A times the jth column of B. So we multiply each entry respectively and then we add them up. Okay, and probably the easier way to understand this as a series of matrix vector multiplication. So you can think of B is like a lot of vectors, a lot of column vectors, and then okay, A times B1 we get C1, A times B2 we get C2. So that's why you can you get here we have P column vectors. Okay. All right. So now let's do this multiplications. So what is C times A? Okay, or C times A. So C times A, what is the size for C 2 by 2? So C is 2 by 2, A is 2 by 3. C times A, what happened? C times A, C is 2 by 2, A is 2 by 3. Okay. Oh, sorry. I think it should be AC. Okay, it's okay. Let's calculate CA first, and then let's calculate AC. So CA match. So the outcome should be 2 by 3. Okay, so now write down the C. C is 3 minus 1 minus 2, 6. A is 3, 0 minus 1, 2 minus 7, 5. Alright, so we use row times column, okay? So the one entry, we use the first row times the first column. So then 3 times 3, and then plus minus 2 times 2. Okay? So we multiply each entry respectively and then add them up. And then for, this is the 1, 1 entry. And then for the 1, 2 entry, we use the first row multiplied by the second column. So we have 3 times 0 plus minus 2 times minus 7. Okay. And then we have the 1, 3 entry is the first row times the third column. 3 times minus 1, and then plus negative 2 times 5. Okay, let me move these to the left. I don't have enough space here. Okay. Alright, so let's continue. Okay, how about the second row? Then we use the second row times the first column, minus 1 times 3, plus 6 times 2. And then first row times second column, minus 1 times 0, 6 times minus 7. And then minus 1 times minus 1, 6 times 5. Okay, what is the answer? This is 9 minus 4, right? And this guy is 3 times 0 is 0. And negative times negative would become positive. 2 times 7 is 14. And then minus 3 minus 10, right? This is minus 3 plus 12. This is 0, and then minus 42. This is 1 plus 30. So the answer is 9 minus 4 is 5. And 14, negative 13. 9 minus 3 is 12 minus 3 is 9. Negative 42. And this is 31. So this is the matrix C times A, okay? How about A times C? So A times C, because A is 2 by 3, C is 2 by 2. You see the inner dimension, they don't match. So we know A times C is not defined. Okay, so this is the matrix multiplication. Alright, let's continue. So here we have another example. So please pause the video and try to work on this example. Right? Are you ready to check your answers? Okay. What is the dimension for A? We have how many rows? 3 rows and 2 columns. What's the dimension for B? We have 2 rows and 4 columns, right? So the size of A is 3 by 2, size of B is 2 by 4. Okay, part A, what is A times B? Well, A times B is okay because the inner dimension match, right? So let's see. A times B, let me copy down A here. B minus 1, 6, 1, minus 1, minus 2, 4, minus 3, minus 1. Okay. Alright, so we use row times column. So here, okay, 1 times minus 1 is minus 1. Plus 2 times minus 2 is negative 4. Okay, so here we also do the calculation. Alright. And then the 1, 2 entry, we use the first row times the second column. 1 times 6 is 6. Plus 2 times 4 is 8. Okay? And then we look at the third column. 1 times 1 is 1. 2 times negative 3 is negative 6. Okay? How about the last column? 1 times minus 1 is minus 1. 2 times minus 1 is minus 2. Okay? Alright, so this is the first row. How about the second row? Minus 2 times minus 1 is 2. 1 times minus 2 is minus 2. Okay, how about second column? Minus 2 times 6 is minus 12. Plus 4 times 1 is 4. And then 1 times negative 2 is negative 2, plus 1 times negative 3 is negative 3. Okay? And then the last one, minus 1 times negative 2 is 2. Minus 1 times 1 is minus 1. How about the last row? Negative 3 times negative 1 is 3. And then 0 times whatever is 0. And then the second column, negative 3 times 6 is negative 18. And 0 times whatever is 0. So actually, we just look at the negative 3 times that, right? Here, negative 3 times 1 is negative 3, and that negative 3 times negative 1 is 3. Okay, so what is this? Minus 1 minus 4 is minus 5. 6 plus 8 is 14. 1 minus 6, negative 5. And then minus 1 minus 2 minus 3. 2 minus 2, 0. And then this is a negative 8, negative 5, 1, 3, minus 18, minus 3, and 3. So this is the answer. Okay. How about part B? How about BA? Well, B is 2 by 4, A is 3 by 2. You can see the inner dimension don't match. So B times A is undefined. You can say it is not defined or it is undefined, the same thing, right? Okay, do you get the same answer with your results? Yes? Good. Let's continue. Alright, so conclusion. Do you see AB is not the same as BA? So matrix multiplication is not commutative. Well, the multiplication of numbers are commutative because like a 3 times 2 is 6, but 2 times 3 is also 6. So multiplication of numbers is commutative. But however, multiplication of matrices is not commutative. So be careful with that. Okay? Yeah, you can see AB is not the same with BA. Alright, next, rules of matrix algebra. So A plus B is B plus A. So addition is commutative. Why is that? Because the addition, we just like add the entries respectively. Well, when we add the entries, it's just like additions of numbers. Addition of numbers is commutative. Okay, and the associative law. So when we add the matrix, we can add the later two matrices first and then add the first one, or we add the first two matrices first and then add the last one. Because when we add the matrix, we just add the entries respectively. When we add the entries, they are just like regular additions of numbers. So additions of numbers is associative and commutative. And the multiplication is associative. So actually we can multiply B, C first and then multiply A on the left. Or we can multiply A, B first and then multiply C on the right. Okay, so multiplication is associative, but be careful, it's not commutative. So on the left or on the right, it really matters. So be careful with that. And then we also have the distributive law. A times B plus C is A times B plus A times C. A plus B times C is A times C plus B times C. Okay? Other notions and special matrices we will need to complete our algebra. Okay, so let's look at the transpose of a vector. So transpose means we just interchange the rows and columns. So for example, let X be the column vector. So this is a column vector, the size is n by 1. And then the transpose, we use this notation. We put a capital T on top of the X. It's like on the power of it. Okay, the transpose is just we change the column, now it becomes rows. So the size now is 1 by n. Okay, what is X times X transpose? Well, X times X transpose we can see here, this guy is, okay, so we have x times x transpose. We use row. Okay, so this is so x is n by 1 and x transpose is 1 by n, so the result is n by n. So we use row times column, so that's why you will see the result is gonna be x ij. So this is a matrix. Xi times xj. Okay, so here I and j goes from 1 to n. So this is a matrix. And what it looks like is, well, x1 times x1 here, and then x1 times x2 there, and then etc. Okay, this is x2 times x1, etc. Okay, and how about x transpose times x? Well, we use row times column, so actually the result is just a number. And what is that? It's x1 squared plus x2 squared plus dot 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 plus xn squared. So that's why we use this notation, summation I from 1 to n, and then we have the xi squared. Oops. Okay, so that is the transpose. Next, example 4. Find the transpose of the following matrices. Alright, so let's see. This is A, and then so A transpose is, okay, so row become column or column become rows. So you can see 1, 5, we put 1, 5 here. 9, 4, second row, now we put it as the second column, 9, 4. And how about B transpose? Okay, 1, 5, 2, 1, 5, 2, 9, 4, 3. Okay, so now let's do some computation. Let's compute B times B transpose. And also let's compute B transpose times B, and let's see how different the results are. Okay, so you can also pause the video here and try to work on this, and then you can check your answers later. Are you ready? Okay, let's check. B is 1, 5, 2, 9, 4, 3. B transpose 1, 5, 2, 9, 4, 3. We use the first row times the first column. 1 times 1 is 1. 5 times 5 is 25. 2 times 2 is 4. And then we use the first row times the second column. 1 times 9 is 9. 5 times 4 is 20. 2 times 3, 6. And then we use the second row times the first column. 9 times 1, 9. 4 times 5, 20. 3 times 2, 6. And then first row times the second row times second column. 9 times 9, 81. 4 times 4, 16. 3 times 3, 9. Okay, so the answer is, well, 1 plus 25 plus 4 is 30. 9 plus 6, 15 plus 20, 35. And do you see this is the same, right? And then 81 plus 9 is 90. 90 plus 116 is 106. So this is the answer. Okay, and how about B transpose times B? Alright, so maybe I can move this up a little bit. Oops, sorry. Okay. B transpose. So 1, 5, 2, 9, 4, 3 times B. B is 1, 5, 2, 9, 4, 3. Okay, let's see. First row times first column, 1 times 1, 1, 9 times 9, 81. And then first row times second column, 1 times 5, 5, 9 times 4, 36. And then times the third column, 1 times 2, 2, 9 times 3 is 27. And then second row times the first column, 5 times 1, 5, 4 times 9, 36. And then times the second column, 5 times 5, 25. 4 times 4 is 16. 5 times 2, 10. 4 times 3, 12. Okay, and then the third row, 2 times 1, 2. 3 times 9, 27. 2 times 5, 10. 4 times 3, 12. And then 2 times 2, 4. 3 times 3, 9. Alright, now what happened? 1 plus 81 is 82. 5 plus 36 is 41. 2 plus 27 is 29. 5 plus 36, 41. 25 plus 16 is 41. Right? 10 plus 12, 22. This is 29, 22, 13. Okay. Do you have the same answer? Alright. Okay. Let's look at these two matrices. What can you tell? Do you realize that, okay, we know this is a diagonal, right? Do you notice that these guys, they are the same? Look at this. This is diagonal, right? Do you see this guy? They're the same. This guy, they're the same. And this guy, they're the same. So it really looks like this is the mirror, right? The diagonal is like the mirror, and then we have these guys. They're like mirror image of each other. And matrix with this property is called symmetric. Okay, so definition. So a matrix A is symmetric if A equals to its transpose. Okay, A equals transpose is like the rows, it's the same as columns. So, and in this case, you can see the entries, the like mirror image across the diagonal elements. So it is like that. So we can see B times B transpose or B transpose times B, the results are symmetric. Okay, so you can see these two guys, they're both symmetric. And this is true for all the matrices. Okay? Alright, so these is definition, and we know that A times A transpose and A transpose times A are symmetric. Okay. So far so good, everyone. Let's continue. Other special matrices, we have the zero matrix. Oh, so all the entries are just 0. Okay, so 0, and let's say assume A and 0 the dimension match. Then 0 plus A is also equals is also equal to A plus 0. And if the dimension of 0 and A match, match means the multiplication defines. Okay, so if A and 0 are both n by n, then the multiplication match. So 0 times the matrix, it just equals to the 0 itself. Okay, because 0 times whatever is 0. So all the entries become 0. Okay, and then we have the identity matrix. So identity matrix is a square matrix with 1 on the diagonal and zeros elsewhere. Okay. And I is the identity matrix, so it plays the role of 1 for multiplications. So suppose A is an n by n matrix, then we have A times I is also equal to I times A. Okay. Alright, so this is a special matrix, 0 matrix, and the identity matrix. Okay, so this is session 3.4. If you have any questions, feel free to ask me. Bye!